Chapter 6 Application of Derivatives Exercise 6.3 or 6.5 in the previous textbook. So first question, that is, find the maximum and minimum values of if any of the following functions given by. First question, that is, f of x is equal to 2x minus 1 whole square plus 3. So what is f dash of x? Then d by dx of 2x minus 1 whole square plus 3. So what is d by dx of 2x minus 1 whole square? That is 2 into 2x minus 1 into d by dx of 2x, that is 2, plus d by dx of 3, that is 0. So we have 2 into 2, that is 4 into 2x minus 1, that is f dash of x. Now we want to find what is second derivative. That means f double dash of x, that is d by dx of 4 into 2x minus 1, or we can write 4 into 2. 2x minus 1 derivative is 2. So f double dash of x is 8. Now we will be finding a critical value, that is f dash of x when it is equal to 0, that is 4 into 2x minus 1 is equal to 0, or we can write 4 is taken to other side, that is 0 itself. So 2x minus 1 equal to 0, x equal to 1 by 2. So at the point at which the x equal to 1 by 2, we are applying that x equal to 1 by 2 in the equation of f double dash of x. What is f double dash of x? That is 8. We don't have the x terms there, so 8 is greater than 0. So we will be getting a minima at x equal to 1 by 2. So we want to find a minimum value at x equal to 1 by 2. So that we are going back to the first equation, that is f of x, equation of f of x, that is 2x minus 1 whole square plus 3. So what is f of 1 by 2? That is instead of x 1 by 2, that is 2 into 1 by 2 minus 1 whole square plus 3, that is 2 1 by 2 minus 1 whole square, that is 0, and plus 3, only 3 remaining. So minimum value is at 3 and there is no maxima for the question. Second question, that is 9x square plus 12x plus 2. So we have f of x is equal to 9x square plus 12x plus 2. So we will be finding what is f dash of x, that is d by dx of 9x square plus 12x plus 2. d by dx of 9x square, that is 9 into 2x. d by dx of 12x, that is 12. d by dx of 2, 0. So 9 into 2, that is 18x plus 12. So when f dash of x is equal to 0, we have 18x plus 12 equal to 0, and x is equal to minus 12 by 18. When it is shortened, it is minus 2 by 3. So x is equal to minus 2 by 3. So we have got the value for x, that is only one value, that is minus 2 by 3. Now after what is f double dash of x? That is d by dx of 18x plus 12, that is 18, which is greater than 0. We don't have to put x value here because there is no x terms for f double dash of x, that is 18, and it is greater than 0. So we can write it is having a minima. So what is the minimum value? That is in f of x, if we are applying x equal to minus 2 by 3, that is f of minus 2 by 3, we have 9x square plus 12x plus 2. Instead of x, we are applying minus 2 by 3, that is 9 into 2 minus 2 by 3 whole square plus 12 into 2 by minus 2 by 3 plus 2. So we have the remaining, when it is solved, that is minus 2. So the minima value is at minus 2 and there is no maxima. Next question, that is third one. That is minus x minus 1 whole square plus 2 plus 10. So we have f of x is equal to minus x minus 1 whole square plus 10. Then what is f dash of x? That is d by dx of minus x minus 1 whole square plus 10. So what is minus x minus 1 whole square? That is minus 2 into x minus 1 into 1 by dx of 10, that is 0. So what is f dash of x? That is minus 2 into x minus 1. When f dash of x is equal to 0, we have minus 2 into x minus 1 equal to 0, and then x equal to, from that x equal to 1. The value of x is 1. Now we will be finding what is f double dash of x, that is d by dx of minus 2x minus 1, that is d by dx of minus 2x minus 1, that is minus 2 into x minus 1, that is 1 itself. So minus 2. So f double dash of x is minus 2, which is less than 0. Since f double dash of x is a negative quantity, we will be having the maxima here. So what is the maximum value? So at x equal to 1, we have to apply that in the f of x. That is f of x is equal to minus x minus 1 whole square plus 10. So f of 1 is equal to minus 1 minus of 1 minus 1 whole square plus 10. That is f of 1 is equal to 10. So the maximum value is equal to 10. So there is no minima value for this question also. So next question, that is the fourth question. G of x is equal to x cube plus 1. So g of x is equal to x cube plus 1. What is g dash of x? That is d by dx of x cube plus 1. That is d by dx of x cube, that is 3x square, d by dx of 1, that is 0. So g dash of x is 3x square. When g dash of x equal to 0, we have 3x square is equal to 0, x equal to 0 here. So what is g double dash of x? That is d by dx of 3x square, that is 3 into 2x, that is g double dash of x is equal to 6x. So we have got g double dash of x when x equal to 0. What is g double dash of x? That is g double dash of 0, that is 6 into 0, that is 0. So at x equal to 0, we have g double dash of 0 is equal to 0. So at this point, neither maxima nor minima, that is which is equal to 0. So neither maxima nor minima. Chapter 6, Application of Derivatives, exercise 6.3, 6.5 in the last year textbook. Question number 2. Find the maximum and minimum values if any of the following functions given by. First question, that is f of x is equal to mod of x plus 2 minus 1. Second, g of x is equal to minus of mod of x plus 1 plus 3. Third, h of x is equal to sine 2x plus 5. Fourth question, that is f of x is equal to mod of sine 4x plus 3. Fifth question, that is h of x is equal to x plus 1, where x belongs to the interval minus 1 to 1. So we have the first question, that is f of x is equal to mod of x plus 2 minus 1. We know that mod of x plus 2 is always a positive quantity. So we can write mod of x plus 2, which is equal to, which is greater than or equal to 0. Now, in the next step, we will be adding minus 1 on both sides. That means on the both LHS and RHS side. That is minus mod of x plus 2 minus 1, which is greater than or equal to 0 minus 1. Or we can, what is mod of x plus 2 minus 1? That is the question, that is f of x. So f of x is greater than or equal to minus 1. So f of x will be from the interval minus 1 to infinity. So here minimum value will be minus 1. So what is the maximum value? We don't have a maximum value, therefore no maximum value. Now second question, that is g of x is equal to minus of mod of x plus 1 plus 3. So here also we have mod of x plus 1, that is always a positive quantity, that means greater than or equal to 0. Now we will be multiplying with a negative sign in both sides. So we have negative of mod of x plus 1. It should be always less than or equal to 0. That means negative quantity less than or equal to 0. Now adding 3 on both sides. So minus of mod x plus 1 plus 3, which is less than or equal to 0 plus 3. Or we can write what is minus of mod x plus 1 plus 3, that is f of x. So f of x, which is less than or equal to 3. So the intervals should be from 3 to minus infinity, or we can write the maximum value will be 3 and the minimum value, we don't have a minimum value, that is no minimum value. Now next question, that is third question, that is h of x is equal to sine of 2x plus 5. So we will be having sine 2x plus 1. So what is the ranges of sine x? That is from minus 1 less than or equal to sine x less than or equal to 1. Here we have sine 2x, that is also from minus 1 less than or equal to sine 2x less than or equal to 1. Now adding both sides with plus y, we have on the left minus all sides, that means minus 1 plus 1 less than or equal to sine 2x plus 5 less than or equal to 1 plus 5. Or what is minus 1 plus 5? That is 4 less than or equal to sine 2x plus 5 less than or equal to 6. Or we can write 4 less than or equal to sine 2x plus 5, that is the question, that is h of x. That means less than or equal to 6. So from this we will be having the minimum value, that is 4, that is from 4, and the maximum value up to 6, that means 4 less than or equal to h of x less than or equal to 6. So we have minimum value 4 and maximum value 6. Now moving on to the next question, that is f of x is equal to modulus of sine 4x plus 3. So we have the ranges of sine x, that is from minus 1 less than or equal to sine x less than or equal to 1, or we can write 4x, that is minus 1 less than or equal to sine 4x less than or equal to 1. So now adding 3 on the both sides, so we will be having minus 1 plus 3 less than or equal to sine 4x plus 3 less than or equal to 1 plus 3, or we can write minus 1 plus 3, that is 2 less than or equal to sine 4x plus 3 less than or equal to 1 plus 3, that is 4. So the ranges of sine 4x plus 3, that is from 2 and to 4. So we have modulus of sine 4x plus 3, right? So modulus of sine 4x plus 3 is always a positive quantity. So we have which should be greater than or equal to 0. That means it should be a positive quantity. So we can write 2 less than or equal to sine 4x plus 3 less than or equal to 4. The condition is satisfied here. So we can write the minimum value is from 2 and the maximum value is up to 4. So minimum value is 2 and maximum value is 4. Now moving on to the next question, the fifth question, that is h of x is equal to x plus 1 where x belongs to the interval minus 1 to 1. So we have given h of x is equal to x plus 1. We have from the interval minus 1 to 1 where the x belongs. So x should be minus 1 less than or equal to x less than or equal to 1. So adding 1 on both sides of the above equation. So minus 1 plus 1 less than x plus 1 less than 1 plus 1. What is minus 1 plus 1? That is 0 less than x plus 1 less than 1 plus 1, that is 2. Or what is x plus 1? That is h of x we have in the question. So 0 less than h of x less than 2. So it has the value between 0 to 2. That is not possible. So we cannot find maximum and minimum value for the question. Why it is not possible? It is because the values of x should be between minus 1 to 1. But we have got it from 0 to 2. So we cannot find maximum and minimum here. Chapter 6, Application of Derivatives, exercise 6.3 or 6.5 in the last year textbook. Question number 3, that is, find the local maxima and local minima if any of the following functions. Find also local maximum and local minimum values as the case may be. First question, that is f of x is equal to x square. So we will be having f of x that is equal to x square. Now we will be finding what is f dash of x, that is d by dx of x square, that is 2x. When f dash of x is equal to 0, 2x equal to 0, x is 0 then. Now what is f double dash of x, that is d by dx of 2x, that is 2. So we know that 2 is greater than 0. Since 2 is greater than 0, it is a positive quantity and we can say we have a local minima here. So the local minimum value we have is f of x equal to x square. We are applying instead of x, that is 0, that is f of 0, that is instead of x square, that is 0 square. So f of 0 is 0 itself. So at x equal to 0 we have the local minimum value and we don't have the local maxima here. Next question, that is the second question, that is g of x is equal to x cube minus 3x. So what is d dash of x, that is d by dx of x cube minus 3x, that is d by dx of x cube 3x square, d by dx of minus 3x, that is minus 3, or g dash of x is equal to 3x square minus 3. What is g dash of x when it becomes 0? That is 3x square minus 3 equal to 0. Taken 3 outside, that is 3 into x square minus 1 equal to 0. So we have the value x square minus 1 equal to 0, or x have the value plus 1 or minus 1. Now what is d double dash of x, that is d by dx of 3x square minus 3, that is 3 into 2x, that is 6x. So g double dash of x is 6x. So we have got g double dash of x. Now at x equal to plus 1 and x equal to minus 1. So at x equal to plus 1, what is g double dash of x? That is g double dash of 1, that is 6 into 1, that is 6, which is greater than 0. That means we are having a local minima here. So what is the local minimum value? That is, we are applying instead of g of x, g of 1. That is g of 1 is equal to 1 cube minus 3, or that is minus 2. So local minimum value is at minus 2. Now what is g double dash of x? At x equal to minus 1, that is g double dash of minus 1, that is 6 into minus 1, that is minus 6, which is less than 0. So we can have a local maxima here. What is g of minus 1? That is minus 1 whole cube minus 3 into minus 1, that is minus 1 plus 3, that is 2. So the local maximum value is 2. So we have got local maximum value and local minimum value. Now moving to the next question, that is the third question, that is h of x is equal to sin x plus cos x where 0 less than x less than pi by 2. So we have the question h of x is equal to sin x plus cos x where 0 less than x less than pi by 2. What is h dash of x? That is d by dx of sin x plus cos x. d by dx of sin x, that is cos x. d by dx of plus cos x, that is minus sin x. So we have cos x minus sin x. When h dash of x is equal to 0, we have cos x minus x is equal to 0, where cos x is equal to sin x. So at the time when cos x is equal to sin x, in between 0 to less pi by 2, the ranges of x should be from 0 to pi by 2. We have the value of x, that is pi by 4 at that time. Now we will be finding what is h double dash of x. That is d by dx of cos x minus sin x. d by dx of cos x, that is minus sin x. d by dx of minus sin x, that is minus cos x. So we have minuses taken outside. So sin x plus cos x, that is h double dash of x. So when h double dash of x at x equal to pi by 4, that is h double dash of pi by 4, that is minus of sin pi by 4 plus cos pi by 4, that is minus of sin pi by 4 1 by root 2, cos pi by 4 again 1 by root 2. So we have minus 2 by root 2, cancelling both numerator and denominator. We have h double dash of pi by 4, that is minus root 2, which is less than 0. So since minus root 2 is a negative quantity, we have the local maxima here. So what is the local maximum value? So h of pi by 4, that is h of pi by 4 is sin x plus cos x. We are applying in that equation, the first equation, that is sin of pi by 4 plus cos of pi by 4, that is 1 by root 2 plus 1 by root 2, that is 2 by root 2, or we have the remaining, that is root 2. So at root 2 we have the local maximum value. So we have got the local maximum value at root 2 and there is no local minima value for this question. Now fourth question, that is f of x is equal to sin x minus cos x where 0 less than x less than 2 pi. So we have f dash of x, that is d by dx of sin x minus cos x. d by dx of sin x, that is cos x. d by dx of minus cos x, that is plus sin x. So we have f dash of x is equal to cos x plus sin x. Now when f dash of x is equal to 0, that is cos x plus sin x is equal to 0. So at that time cos x is equal to minus sin x. So in between the value 0 less than x less than 2 pi, we have two values for x that satisfy the condition cos x is equal to minus sin x. That is, x can be neither 3 pi by 4 or 7 pi by 4. So we have two values in between 0 to 2 pi for x. So we have f double dash of x, that is d by dx of cos x plus sin x, that is minus sin x plus cos x. Now when f double dash of x at x equal to 3 pi by 4, that is f double dash of x is equal to minus sin 3 pi by 4 plus cos 3 by 4 at x equal to 3 pi by 4, that is minus 1 by root 2 minus 1 by root 2. So we have minus 2 by root 2, that is minus root 2. Minus root 2 is less than 0, so we have the local maximum value here. What is the local maximum value? That is f of x. We are applying it in the equation sin x minus cos x. So f of 3 pi by 4 is equal to sin 3 pi by 4 minus cos 3 pi by 4. That is 1 by sin 3 pi by 4. That is 1 by root 2, cos 3 by 4, again 1 by root 2. So we have the value that is root 2, that is the local maximum value. Now at x equal to 7 pi by 4, we have f double dash of x, that is minus sin x plus cos x, right? Minus sin of 7 pi by 4 plus cos 7 pi by 4. That is minus of 1 by root 2 plus 1 by root 2. So we have the answer root 2, which is greater than 0. So we will be having a local minima here. So what is the local minimum value here? That is f of 7 pi by 4, which is equal to sin of 7 pi by 4 plus cos of 7 pi by 4. So when we solve, we have the answer minus root 2. So the local minimum value is minus root 2. Fifth question, that is f of x is equal to x cube minus 6x square plus 9x plus 15. So we have f of x is equal to x cube minus 6x square plus 9x plus 15. We will be finding f dash of x, that is d by dx of x cube minus 6x square plus 9x plus 15. D by dx of x cube, that is 3x square. D by dx of minus 6x square, that is minus 6 into 2x. D by dx of 9x, that is 9, and d by dx of 15, 0. So we have 3x square minus 12x plus 9, or we have taken 3 outside, x square minus 4x plus 3, or x square minus 4x plus 3 can be written as x minus 1 into x minus 3. So we have 3 into x minus 1 into x minus 3. That is f dash of x. When f dash of x equal to 0, 3 into x minus 1 into x minus 3 equal to 0. From this we can write x equal to 1 or x equal to 3. We have two values for x. Now what is f double dash of x? That is d by dx of 3x square minus 4x minus 3, or 3 into d by dx of x square, that is 2x, d by dx of minus 4x, that is minus 4, d by dx of 3 is 0. So we have f double dash of x is equal to 6x minus 12. At x equal to 1, we have f double dash of 1, that is 6 into, instead of x 1, that is 6 into 1 minus 12, that is minus 6. So we have minus 6 as f double dash of 1, that is less than 0. So it is a local maxima. So what is local maximum value? That is f of x is equal to f of 1. We are applying it in the equation f of x, that is x cube minus 6x square plus 9x plus 15. So 1 cube minus 6 into 1 square plus 9 into 1 plus 15. By solving, it will be 19. So we have the local minimum value, that is 19. Now at x equal to 3. So we have f double dash of 3, that is 6x minus 12, that is 6 into 3 minus 12, that is 18 minus 12, that is 6. 6 is greater than 0, that is a positive quantity. So we have a local minima here. What is local minima value? That is f of x is equal to f of 3, that is x cube minus 6x square plus 9x plus 15, that is 3 cube minus 6 into 3 square plus 9 into 3 plus 15. So that is the answer is 15. So local minima value here is 15. Moving into the next question, we have the sixth question, that is g of x is equal to x by 2 plus 2 by x, where x is greater than 0. So we have g dash of x, that is d by dx of x by 2 plus 2 by x. What is d by dx of x by 2? That is 1 by 2. d by dx of 2 by x, that is 2 minus 2 by x square. So we have g dash of x is equal to 1 by 2 minus 2 by x square. What is, when g dash of x is equal to 0, 1 by 2 minus 2 by x square is equal to 0, or x square minus 4 equal to 0, or x, we have two values, that is plus 2 or minus 2. So what is g double dash of x? That is d by dx of 1 by 2 minus 2 by x square, or d by dx of 1 by 2, that is 0, d by dx of minus 2 by x square, that is minus 4 by x cube. So minus into minus plus, so plus 4 by x cube. So d double dash of x is equal to plus 4 by x cube. At x equal to plus 2, we have g double dash of x, that is 4 by x cube, that is 2 cube, that is 4 by 8, that is 1 by 2. So it is greater than 0. So g double dash of x, when it is greater than 0, we have the local minima here. So what is the local minimum value? That is g of x is equal to x by 2 plus 2 by x, applying in that equation. So g of 2, that is 2 by 2 plus 2 by 2, that is 2. So we have the local minima value is equal to 2. So Now at x equal to minus 2, we have g double dash of minus 2, that is 4 by x cube, right? 4 by minus 2 whole cube, that is minus 1 by 2, which is less than 0. But in the question, we have said that x should be greater than 0. So there is no possible value here. Next, 7th question, that is g of x is equal to 1 by x square plus 2. So we have given g of x is equal to 1 by x square plus 2. Then what is g dash of x? That is d by dx of 1 by x square plus 2. 1 by x square plus 2 can be written as x square plus 2 whole raised to minus 1. So d by dx of x square plus 2 whole raised to minus 1, that is minus 1 into x square plus 2 whole raised to minus 2 into d by dx of x square, that is into 2x. So we have g dash of x is equal to minus 2x by x square plus 2 whole square. When g dash of x is equal to 0, we have minus 2x into x square plus 2 whole square is equal to 0, or minus 2x is equal to 0, or x is equal to 0. Now we are not moving into g double dash of x because we will be finding it from the g dash of x. We will be finding local maxima, local minimum value here. So let us consider the case of g dash of x when x is less than 0 and when x is greater than 0. So slightly less than 0 or slightly greater than 0. When in the case of x. So what happens when x is less than 0? That is g dash of x, applying it in the equation of g dash of x, that is will be a positive quantity. Similarly, when x is greater than 0, g dash of x will be a negative quantity. So now when we draw a graph with these quantities, we will be having a graph from positive into the negative. So from this we can conclude that we have the local maxima at x equal to 0. So at x equal to 0 we will be having the local maxima and the local minimum max. What is local maximum value here? That is g of x, that is g of 0, that is 1 by x square plus 2, that means 1 by 0 square plus 2, that is 1 by 2. So at 1 by 2 we have the local maximum value here and there is no local minimum. Now 8th question, we have g of x is equal to x root 1 minus x where x is less than 1. So we have f of x is equal to x root 1 minus x where x is less than 1. So what is f dash of x? That is d by dx of x root 1 minus x. So we are applying the product rule here, that is x into d by dx of root 1 minus x plus 1 root 1 minus x into d by dx of x, or x into d by dx of root 1 minus x, that is 1 by 2 root 1 minus x into d by dx of minus x, that is minus 1, plus root 1 minus x into d by dx of x, that is 1. Or we can write minus x by 2 root 1 minus x plus root 1 minus x, or by cross multiplying we have minus x plus root 1 minus x into 2 root 1 minus x, root cancel, we have 2 into 1 minus x divided by 2 root 1 minus x at the denominator. Or we can write by solving the bracket we have minus x plus 2 minus 2x by root 2 root 1 minus x, or minus x minus 2x, that is 2 minus 3x divided by 2 root 1 minus x. So we have got what is f dash of x. So that is 2 minus 3x divided by 2 root 1 minus x. Now we will be considering when f dash of x is equal to 0, that means 2 minus 3x by 2 root 1 minus x is equal to 0, or from this 2 minus 3x is equal to 0. So the value of x will be 2 by 3. By solving we will be having x equal to 2 by 3. So from this we can write same as the above question, we will be considering f dash of x here. Here the x should be less than 2 by 3 and greater than 2 by 3. So when in the case when x is less than 2 by 3, we have f dash of x, applying in the equation 2 minus 3x divided by 2 root 1 minus x. We will be having f dash of x a positive quantity. Similarly, when x is greater than 2 by 3, we are applying in the same equation f dash of x, we will be having the quantity as a negative one. So we can say that when x is less than 2 by 3, we have f dash of x is positive, and when x is greater than 2 by 3, f dash of x is negative. So by drawing a graph, we can see the graph is from positive into the negative. So what is the local maxima here? That is 2 by 3. at x equal to 2 by 3 we have the local maxima. What is the local maximum value? That is f of x, that is what is the f of x, that is x root 1 minus x. So we are applying instead of x 2 by 3, that is 2 by 3 root 1 minus 2 by 3. By solving we have 2 by 3 into root 1 by 3 or 2 root 3 by 9. So at 2 root 3 by 9 we have the local maximum value. Question number 4, that is prove that the following functions do not have maxima or minima. First question, that is f of x is equal to e raised to x. So what is f dash of x? That is d by dx of e raised to x. That is e raised to x itself. Now again, what is f double dash of x? That is d by dx of again e raised to x, that is e raised to x itself. So when f dash of x is equal to 0, we can write e raised to x is equal to 0. Here the condition is not possible because e raised to x cannot be 0 for any real number of x. So there is no a real number x for which the e raised to x cannot be equal to 0. So we can say that there is no maxima or minima for this question. Next question, that is g of x is equal to log x. Now what is g dash of x? That is d by dx of log x, that is 1 by x. So when g dash of x is equal to 0, we can write 1 by x is equal to 0. So at this time we will not find a value for x. So this is not a possible condition because here the x should be greater than 0, right? So there is no possible value here. So we can write there is no a critical value for g dash of x. So there is no maxima or minima for the given g of x value, that is log x. Third question, that is h of x is equal to x cube plus x square plus x plus 1. Now what is h dash of x? That is d by dx of x cube plus x square plus x plus 1. What is d by dx of x cube? That is 3x square. D by dx of x square, that is 2x. D by dx of x, that is 1. D by dx of 1, 0. So we have h dash of x, that is 3x square plus 2x plus 1. When h dash of x is equal to 0, we can write 3x square plus 2x plus 1 is equal to 0. And this is a form of a quadratic equation, but we cannot find a real root for x. So how it is possible? So let us use the condition to find x here. So x is equal to minus b plus or minus root b square minus 4ac by 2a. We are using that equation here. So if we use that equation here, we will be substituting the value for b, a and c. We have minus 2 plus or minus 2 whole square minus 4 into ac, that is 4 into 3 into 1 whole divided by 2 into 3. Or by solving this we have minus 2 plus or minus inside the root, that is minus 8. Root minus 8 divided by 6, that is x is equal to minus 2 plus or minus root minus 8 by 6. But root minus 8, it is not a possible value. It is not a real number and it's not a possible value. So we can find no maxima or no minima here. So there is no maxima or minima for this above question. Question number 5. Find the absolute maximum value and absolute minimum value of the following functions in the given intervals. In that first question, that is f of x is equal to x cube, where x belongs to the interval minus 2 to 2. So what is f dash of x? That is d by dx of x cube, that is 3x square. So at f dash of x is equal to 0, we can write 3x square is equal to 0. From that x is equal to 0. So we have the x belongs to the interval minus 2 to 2. So the values of x will be, in order to find absolute maximum and absolute minimum, it should be minus 2, 0 and 2. It is because it is from the interval minus 2 to 2. So we'll be taking the values of x, that is minus 2, 0 and 2. First, at x equal to minus 2, we have f of x is equal to x cube, or f of minus 2 can be written as minus 2 whole cube, that is minus 8. Now we will be finding what is at x equal to 0. The next value of x, that is f of 0, that is f of 0 means 0 whole cube. F of x is x cube, so f of 0 is 0 whole cube, that is 0 itself. And at x equal to 2, that is f of 2, which is equal to 2 whole cube, that is 8. So from these we can write at minus 8 we have the absolute minimum. It is the least value in given x equal to minus 2. And at x equal to 2 we have 8 and it is the maximum value we have. So at 8 we have having the absolute maximum value. Second question, that is f of x is equal to sin x plus cos x, where x belongs to the interval 0 to pi. So we have given f of x is equal to sin x plus cos x. So f dash of x is equal to d by dx of sin x plus cos x. That is d by dx of sin x, that is cos x, d by dx of plus cos x, that is minus sin x. So f dash of x is cos x minus sin x. When f dash of x is equal to 0, we can write for cos x minus sin x is equal to 0. By solving, we have cos x is equal to sin x. So in between the interval 0 to pi, we have only one value that satisfies the condition cos x is equal to sin x, that is at x equal to pi by 4. So the values of x will be 0, pi by 4 and the pi. It is because of the interval 0 to pi. First, when at x equal to 0, we have f of x, that is sin x plus cos x, right? So f of 0, that is sin of 0 plus cos of 0. Sin of 0, 0, cos of 0, 1. So we have f of 0 is 1. At x equal to pi by 4, we have f of pi by 4, that is sin pi by 4 plus cos pi by 4, that is 1 by root 2 plus 1 by root 2, that is by solving it will be root 2. And similarly at x equal to pi, we have f of pi, that is sin pi plus cos pi, that is what is sin pi, that is 0, cos pi is minus 1. So we have f of pi is equal to minus 1. So among these three values we can write root 2 is the greater value and minus 1 is the lesser value. So at minus 1 we have the absolute minimum, and at root 2 we have the absolute maximum. So the absolute maxima value is root 2 and absolute minima value is minus 1. Now moving into the third question, that is f of x is equal to 4x minus half x square, where x belongs to the interval minus 2 to 9 by 2. So we have given f of x is equal to 4x minus half x square. So what is f dash of x? That is d by dx of 4x minus half x square. d by dx of 4x, that is 4 itself, d by dx of half x square, that is minus half into x square, that is 2x. So we have f dash of x, that is 4 minus x. When f dash of x is equal to 0, 4 minus x is equal to 0. From this, x value of x is 4. So we have the interval, that is from x belongs to minus 2 to 9 by 2. So the values of x will be, the three values will be there, that is minus 2, 9 by 2 and 4. So minus 2, 4 and 9 by 2 are the three values of x. So at x equal to minus 2, what is f of x? That is 4x minus half x square. Substituting instead of x minus 2, that is 4 into minus 2 minus half into minus 2 whole square. So by solving 4 into minus 2, that is minus 8, half into minus 2 whole square, that is minus 4. So minus 4 by 2. So we have minus 8 minus 2, that is minus 10. So f of minus 2 is minus 10. Now next value of x, that is x at x equal to 4, we have the same equation, that is f of x is equal to 4x minus half x square, that is f of 4 is equal to 4 into 4 minus half into 4 whole square, that is 4 into 4 16 minus half into 4 whole square, that is 8. 16 minus 8 is 8. So now at x equal to 9 by 2, we have f of x is equal to 4x minus half x square. So f of 9 by 2, that is equal to 4 into 9 by 2 minus half into 9 by 2 whole square. By cancelling 4 and 2, we have the remaining 2. So 9 into 2 minus half into, that is 36 by 2 minus 81 by 8. By solving, we have 63 by 8. So we have absolute minimum, that is minus 10, and the absolute maximum, that is 8. 8 is greater than 63 by 8. So at maximum value at x equal to 8 and a minimum value at minus 10. Now moving into the fourth question, that is the last question in this section, that is f of x is equal to x minus 1 whole square plus 3. So f of x is equal to x minus 1 whole square plus 3, where x belongs to the interval minus 3 to 1. So what is f dash of x? That is d by dx of x minus 1 whole square plus 3. That is 2 into x minus 1 into d by dx of x, that is 1 itself. So f dash of x is equal to 2 into x minus 1. When f dash of x is equal to 0, 2 into x minus 1 is equal to 0, or at this time x equal to the value of x is 1. So the values of x will be minus 3. It should be from the interval minus 3 to 1, right? So here we have got x equal to 1. So we have two values for x, that is minus 3 and 1. So at first case, when x is equal to minus 3, we have f of x, that is the question, that is x minus 1 whole square plus 3. So f of 3 will be f of minus 3 will be minus 3 minus 1 whole square plus 3, that is minus 3 minus 1 minus 4 whole square plus 3, that is 16 whole square plus 3, that is 19. At x equal to 1, f of x is equal to, similarly, f of 1 minus 1 whole square plus 3, that is 3 itself. So we have 19 is the maximum value, so absolute maximum at 19, that is the absolute maximum value, and 3 is the minimum value, so absolute minimum value is 3.